Welcome. This is Chemistry and Society, and this is just to give you a brief introduction to what this course is about. The objective of this introductory course is for non science major. The course emphasizes conceptual topics in chemistry and scientific thinking. Students learn to understand how society uses chemistry based technology and how to analyze current trends or news involving chemistry. Topics include a basic understanding of matter and energy, physical and chemical changes, the atom, nuclear chemistry, bonding, acids and bases, organic chemistry, and biochemistry, just to name a few. Current issues in environmental chemistry, such as energy resource, air and water pollutions, are explored. Students discuss the effects and controversy surrounding the use of different forms of energy. This course will give you the knowledge to make wise decisions when topics like this crosses your path. So, why are you taking this course? Rarely do I hear the answer that it's your favorite course. Generally, it's required for your major or that you want a better, well rounded science education. This course will give you a better understanding of how science impacts societies, however. Um, Science is important because your doctors and nurses have science background. They may have even taken chemistry. The brewmaster actually have a knowledge of chemistry in order to the fermentation process of making uh, beer and wine. People who are concerned about the environment need some knowledge of chemistry. Even the lab tech who analyzes your blood in the hospitals need to understand a little bit about chemistry. So you can see that chemistry is being used in all walks of life, and you'll be amazed how much of this science impacts your life. Science, it's actually not Latin for knowledge. Knowledge in science is more than a collection of facts. It involves comprehension, correlation, and ability to explain established facts, usually in terms of physical cause for an observed effect. Carl Sagan said it best: science is more than a body of knowledge, it is a way of thinking, a way of skeptically interrogating the universe. And Stephen Hawking said that scientists have become the bearers of the torch of our discovery of our quest for knowledge. Science and the universe. How is science and the universe related? Well, science encompasses the universe. A better understanding of our universe leads to the improvement to our quality of life. If you think of our universe, there's really just two main entities. Um, this regarding the spiritual and effect, but you can break the universe into matter and energy. Matter, like your desk, your computer, and energy, the the light that you see or the heat that you feel. These two, matter and energy, are related by Einstein's famous equation, E equals mc squared. So back in 1996, I was teaching this course, and there was this scenario. Let me read it to you because I think it exemplifies how much technology has grown based on science. It is the latter part of the 19th century, 1896 to be exact. I am overcome with grief. My youngest child is burning with fever. The sickness has spread from her ear to her entire body. Her skin has a scarlet look and she is in great pain. The doctor has applied some tincture of iodine, but he does not know the cause of what ails her. He has told us to make arrangement. My beloved child will not see her fourth birthday. The next is takes occurs in 1996. It is the latter part of the 20th century, 1996 to be exact. My daughter was ill yesterday with an earache. Our, pedi- our pediatrician diagnosed a streptococcus infection and administered the antibiotic amoxicillin. My daughter thought it tasted great, and she is back in preschool today, completely free of fever and pain. Next, the scenario takes us 10 years from now, 2026. And believe it or not, this is already being prescribed to parents who have knowledge of this. It is the early part of the 20th century, 2026 to be exact. We have chosen to have a daughter. Unlike most of today's parents, we will not pre-select her IQ. However, we do agree with our genetic counselor that her system should be genetically engineered so that she will be immune to all known bacterial and viral infection. So within a span of a little bit more than 100 years, probably 150 years, we go from being affected by bacterial and viral infection that can kill us to pre-programming our children to not have that infection. Wow. So which came first, science or technology? Science feeds technology. Science itself can't cause change. Likewise, technology cannot happen without science. Examples of science or symbiotic relationship to technology was the discovery of the atom. A better understanding of the atom led to the nuclear age, in which we were able to apply or get technology in medical application like MRI imaging or CAT scan, as well as military weapons of mass destruction like the nuclear bomb, as well as consumer product like nuclear energy. So you can see that again, this is a case of science and technology bringing some useful and some destructive application into our society. Another example is when we take hydrogen and oxygen and we combine them to form water, which is pretty harmless liquid, we do get a lot of energy from that. In fact, the space shuttle works based on that fuel. When hydrogen and oxygen are combined, it releases a lot of energy. So how is science different from technology? Well, basic science is the accumulation of knowledge about the universe requires adhering to logical guidelines. These guidelines is called scientific method. Technology is defined as using scientific knowledge to manipulate nature. To make science translate to technology, science must be great problem solver. Some of the problem solving that they do is in today's world is making better batteries. Our car batteries are still that design hasn't changed very much. The car battery that you see today in our cars are no different from what was first brought in the 1930s, 1940s. But the AA and AAA batteries have become have been refined. These days we do have alkaline batteries and rechargeable batteries, but these things don't work in our cell phones and our computers. These days we use lithium batteries, but again, we gotta use science so that we don't invent a battery that blows up in our face like the Samsung Nook, in which the lithium would just spontaneously burn. So the time incubation before technology is realized after an innovation was conceived by science. These are just some examples of the symbiotic relationship between science and technology. Antibiotic was first conceived in 1910. The application was realized in 1940. That's a 30-year incubation period. Heart pacemaker was conceived in 1928, but the first heart pacemaker wasn't put into use until 1960. That's a 32 years incubation period. Nylon, that chemical was first conceived in 1927. We finally made nylon stockings and parachutes in 1939. That's a 12-year incubation period. Xerox, our copying machine. What would we do without it? That was first conceived in 1935. The first machine was invented in 1950. That's a 15-year incubation period. And photography, that was first conceived in 1782. and the application was realized in 1838. That's a 56 years incubation period. So today back in the turn of the century, we saw two great technological revolution. These were the computer chips and recombinant DNA. These days we have supercomputers. Our desktop computers are so much more stronger. Even the computers in our cell phone is so much more stronger than the computers that was used to man the Apollo mission. And recombinant DNA, we can now manipulate nature so that we can eliminate disease or put in certain characteristics in living systems based on changing the genes. Technology doesn't come without a price, however. Risk and benefit of a technological society. There are many benefits of a technological society, but what sacrifice must be paid? What is the risk? Well, if you think about pesticides, these are very important because it improves crop yield, especially with the explosion of population. And yet, there was an accident, deadly accident in India where a chemical manufacturing plant leaked out the chemical and it killed over 2,000 people. That was Union Carbide, the manufacturing company. And we all know about Chernobyl, the nuclear disaster in which there was a meltdown. Hundreds of people died, and that land is useless today. The space travel, well, we know about the Challenger disaster as well as the Apollo disaster. These things happened because an O-ring seal in the Challenger disaster broke because of the cold weather. Automobiles, well, those are one of the biggest pollutants in our society. But back in the 1970s, did you know we were using leaded fuel? Lead is a very toxic chemical that affects our central nervous system and cause people to go to be affected mentally. So, what are acceptable risks? Well, society tend to view and judge involuntary exposure to activities and technologies riskier than voluntary exposure. What does this mean? It means that if we choose to expose ourselves, like lighting up a cigarette or smoking marijuana, then it's okay because that's a voluntary exposure. So we take the risk of that. But if it's involuntary, like living next to a nuclear power plant or seeing toxic chemicals dumped in our backyard, then that's very risky. As a society, we need to judge that and realize that there's always going to be risk and benefits. And it's up to us through science education to make that judgment. Take, for example, this article that was printed in 1999. It talks about the ill effects of chemicals and that all chemicals are bad. But if you read the article, what you will find out is that it's this misconception about all articles, and that you should always read your source and double check your the validity of anything that you read. Well, let me just read a few excerpts of this article. Remember that dioxin scare? Back in the early 1980s, the Environmental Protection Agency pronounced it was the deadliest chemical known to humanity. By 1991, this is about 11 years later, the federal government was forced to admit that it was wrong, that dioxin was virtually harmless. If dioxin is a carcinogen, it is a very weak carcinogen, conceded Dr. Vernon Husk, the federal official who needlessly ordered the evacuation of an entire town in 1983 that was supposedly contaminated by the chemical. How about the radon scare? In the early 1990s, the EPA calculated that the radioactive gas to which an unsuspecting individual may be exposed to when he or she takes his or her daily shower, the public was warned that this gas was responsible for as many as 30,000 lung cancer deaths each year. Yet, as it turned out, none of the cities or states or regions of the country with high readings of radon, which is produced by decaying natural deposits of uranium, by the way, have higher than normal rates of lung cancer. Moreover, not one lung cancer patient has been identified whose illness has been positively attributed to radon. Now we go to the MTBE scare. Methyl tetrabutyl ether is a gasoline additive. The chemical has been around since 1979. In the 1990s and early 2000s, it was used in our gasoline when it was initially added to fuel to increase the octane, but ExxonMobil and Arco and Chevron's have greatly increased its use over that time period. That's because MTBE is what is known as an oxygenated chemical. Cars and trucks fueled by oxygenated gas emits less smog-polluting compounds from their tailpipe than those using old-fashioned non-oxygenated gas. It is for this reason that a 1990 amendment to the Clean Air Act required oxygenated gas to be used in smoggy LA. In San Diego, which has the misfortune of being downwind from the LA and 8 other metropolitan areas throughout the country, which at the time were suffering from poor air quality. And since 1995, when service stations throughout California began selling gasoline reformulated with MTBE, the oxygenated is credited with reducing carbon monoxide pollution by roughly 10% in LA and San Diego, much to the better health of 10 million or so inhabitants in Southern California, 2 largest metropolitan in that area. Alas, this does not sit well with the environmental left, not because they are against clean air, but because they simply don't like the chemical, like MTBE, no matter how beneficial they may be. They believe as an article of faith that chemicals are bad, are injurious to health, and that chemical industry is unholy and its executive evil. As to the problem of MTBE leaching into municipal water supplies, which is why it was phased out, that was nothing whatsoever to do with the chemical properties and everything to do with the failure of oil companies to keep their underwater ground storage facility properly maintained. It should also be mentioned that when underground gas leaks, the biggest danger to the water supply is not MTBE, but benzene and toluene, 2 indisputable cancer-causing chemicals. MTBE has done much to improve air quality in Southern California and other smoggy, car-infested regions of the country. It would be ludicrous for lawmakers to accede to the wish of scaremongers, environmentalist crusaders who seek to ban this oxygenated chemical, not because it poses a scientifically proven threat to human health, but simply because these latter-day Ludies never met a chemical they didn't like. So this was a editorial in the Union Tribune. So the bottom line is there is no doubt that no absolute answer to the question how safe is safe. It is difficult to determine risk. To assess risk, knowledge of toxicity and exposure is required. Exposure. This is easily measured and it's based on the amount of time exposed and quantity of the material. Toxicity. This is difficult to measure. How can toxicity be determined? Human population? It's unethical. Statistical analysis? It's very vague. Animal studies? Well, PETA would get in your case. So it's very hard to measure toxicity. But as a consumer group, we have a responsibility to make decision. We as a consumer should know how to weigh the risks and benefits, and hopefully after this class you will be able to understand the science behind certain consumer goods so that you can make sound judgment. Sound decisions comes from knowledge and a good understanding of science. Science is basically math, which is the language of science, biology, which is the science of the living, physics, which is the science of the way things work, and chemistry, which is also called the central science because it is the building block of matter. I like to call chemistry Lego science. It's called Lego science because if you think about matter, matter is made out of atoms, and atoms are the building block of everything that we see. Well, you can take Lego, and if you go to Legoland, you can see that they make a lot of things. So, anything that contains substance, occupies space, and has mass, well, that's matter. Mass is a quantity, weight is a force due to gravity. Don't confuse weight with mass. Since matter is everywhere, chemistry must be everywhere. When we look at chemistry, we look at the very small and the very large. 10 to the minus 12, that's a subatomic, that's the size of atoms, and smaller. 10 to the minus 6, that's microscopic size. The cells, virus, DNA are of that magnitude. Macroscopics, that's the size of a pen, cars. 10 to the 9th is the size of galaxies and planets. Here's a little video to let you see how big and how small our universe happens to be. So we started at about 10 to the 23rd, and now we're zooming in. 10 to the 11th, 10 to the 10th, 10 to the 9th, 10 to the 4th is about a kilometer. Now we're about the size of a meter. Now we're about the size of a centimeter. Micrometers. We're now the size of a nanometer and the size of a picometer. Now we're going to the interior of an atom. 10 to the minus 16. Now let's go and reverse this. We're at 1 femtometer. And now we're about picometer, 10 to the minus 12. 10 to the minus 9th is a nanometer. 10 to the minus 6 is a micrometer. 10 to the minus 4 is a millimeter. We just passed a centimeter. Now we're at a meter. Now we're at a kilometer. 1,000, 10,000 kilometers. 10 to the 9th. And we're going to space and beyond. 10 to the 20th, 21st, 22nd, the Milky Way galaxy. 10 to the 23rd. So, this is just a brief introduction of chemistry and how it relates to our universe.